So this is interactive display by Multitouch.
And that's the name of your company is Multitouch?
Multitouch is the name of the company.
Okay.
We have a technology which enables you to stack multiple LCD displays together and make them act as one continuous interactive wall. We support different types of interaction, hands obviously, but as well we can do IR pens for annotation. And through optical markers like this, we also can see real-life objects like a eraser in this case.
And you've got one of these at table size as well here, right?
The table here is fully integrated, so it has also the computer that runs the application. So the only thing that you need, apart from this table, is really the power cord.
Right. So you were saying earlier that if I pick a video here, it will automatically point towards me as I look at it.
We track whole hands, not just fingertips, which means that we know the orientation of the hand. So if you point something or tap something, we know the way you are facing that content.
Right. And it will handle multiple people doing multiple things on the screen.
We support unlimited number of people, unlimited number of touch points at the same time.
An unlimited number of birds as well, obviously.
Birds as well.
That's great. It's fantastic. And what's the resolution of this?
This is 1080p, it's full HD. And if you combine displays, you put multiple displays together, up to 24, you get multiples of full HD. So if you put 24 of them together, you get 24 times 1080p.
Great. Okay, thank you very much.
I'm Eric Welch, I'm from the Franklin Institute.
So you're going to show us what exactly is this? It's augmented reality of some sort, right?
Yes, so this is the classic Bernoulli blower with a layer of augmented reality over it. So what we're showing here are the vector lines of the laminar flow around the ball. So the way that this is working is it's using our new aerial software to do blob tracking. So it's looking for the most red thing in its camera view, and then it's applying the center of that object to the algorithm behind it.
So it's not actually measuring the flow, it's calculating what the flow could be.
Yes, yes,
okay.
Exactly.
Very cool. That's a great way for kids to catch on to it, eh?
Yeah, it gives a visual to something that you can't normally see.
Right.
And that's actually a goal for all of these devices that we're playing with. They're all classics. So we have a gravity well, a magnet demo, and they all show forces that you wouldn't normally be able to visualize.
Let's take a look at the magnet.
Sure.
Okay, so then we're looking at flux, lines of flux, right?
Yeah, so we're showing the magnetic fields and how they're interacting. So normally with this device, what you'd be able to experience is you'd be able to feel the forces, but on screen we're showing exactly what those magnetic field lines are doing.
Fantastic. And again, it's not really the magnetic field lines, it's a
under the table we have potentiometers that are registering the locations of the magnets.
Okay. Yeah.
So then that's getting applied to our algorithm.
Very cool. Very cool. The gravity well?
Yes.
Okay.
So I'm going to drop the ball in. Yeah, so what we're doing here is actually background differencing. So when I drop the ball in, it took a picture of the well without the ball in it. And now what it's doing is it's constantly looking for something that's different than that first picture. And if there's something different there, it draws a line. So it's able to track the ball's movement and show those vectors.
So this is different from the other ones in that it really is tracking the object.
Really tracking the object.
Yeah. That's a great demo.
And what's really exciting about all this stuff for us is that these are kind of all out to a prototype level. And what we've done is we've constructed the software for developing these. So we have a programming language that's based in a visual coding language. So there's blocks and nodes that you can connect to quickly get into making these experiences. So that software is designed for content developers, exhibit designers, people who aren't used to working in a coding environment to kind of get to those experiences quickly.
Fantastic. Thank you.
Sure.
Hi, I'm Andrea Stark. I'm the marketing assistant at Weather Underground. We are here at the ASTC conference this year. We were actually the first weather website on the internet back in 1995, and we're here today to really introduce the science behind the weather. As you can see to our left is an example of something that we did for a museum in Dallas involving radar loops. Basically exploring the different types of radar loops that they're able to see on our site and educate the public on how to look at a radar loop, how to understand it, and better use our site and technology. Another application that we have is the Wonder Map, which is available on our website 24/7. We are able to tailor it to each individual science center or museum's needs based on what they're looking for. If they're looking at radar, satellite, what record extremes for weather, or they just want their local forecast. We're basically here to explain the science behind weather and how you can make your science center even better today.